Welcome to Daikin web-based training. In this course, we will be learning about the standard operation state of air conditioners. In order to determine whether an air conditioner is operating properly, you must know the standard values, such as operating pressure and temperature, at each point in the air conditioning system. Let's take a look at what we will be learning today. We will first take a look at the operation state during cooling, namely the standard operating conditions during cooling, measuring points and methods of measurement with regard to the indoor unit, measuring points and methods of measurement with regard to the outdoor unit, and standard operation state during cooling. We will then learn about the standard operation state during heating. The standard operating conditions during cooling, or in other words, the summer test conditions specified in the Japanese industrial standards, are outdoor temperatures of 95 degrees Fahrenheit dry bulb and 75 degrees Fahrenheit wet bulb, and room temperatures of 81 degrees Fahrenheit dry bulb and 66 degrees Fahrenheit wet bulb. Under the standard operating conditions of cooling in the summer, where R410A refrigerant is used in an air conditioner, what would the temperature and pressure levels be in the various points of the indoor and outdoor units? Let's take a look at these levels using the refrigeration cycle of an air-cooled air conditioner. With regard to the cooling operating conditions in the summer, where R410A refrigerant is used in an air-cooled air conditioner, we sequentially check the temperature and pressure at 6 points in the indoor unit, namely the evaporator side, and 7 points in the outdoor unit, namely the condenser side. Let's first take a look at the low pressure level. During cooling operation at a room temperature of 81 degrees Fahrenheit, attach a gauge manifold to the outdoor unit and read the pressure value on the low pressure gauge. It reads 121.8 pounds per square inch. Next, let's determine the evaporation temperature. Obtain the evaporation temperature on the saturation curve for R410A using the low pressure level measured with the low pressure gauge. The low pressure level is 121.8 pounds per square inch, so the evaporation temperature is 41 degrees Fahrenheit. Let's now measure the suction gas temperature. Measure the surface temperature of the outdoor unit's suction gas pipe, which can be considered as the suction gas temperature. The suction gas temperature is 52 degrees Fahrenheit. Let's now determine the superheat temperature. We can find this out from the difference between the suction gas temperature and evaporation temperature. The suction gas temperature is 52 degrees Fahrenheit, and evaporation temperature is 41 degrees Fahrenheit. Therefore, the superheat temperature is 11 degrees Fahrenheit. Next, let's measure the discharge temperature. When the room temperature, or suction temperature, is 81 degrees Fahrenheit, the discharge temperature is measured as 54 degrees Fahrenheit with a digital thermometer. To measure the discharge temperature, set the airflow during cooling to the maximum and measure after the unit has been operating for 15 minutes. Divide the air discharge surface equally, measure at different points along the surface, and calculate the mean value. The indoor air temperature difference is the difference between the suction temperature of 81 degrees Fahrenheit and discharge temperature of 54 degrees Fahrenheit. That is 27 degrees Fahrenheit. The values in the table summarize the pressure and temperature levels on the indoor unit side under the standard operating conditions during cooling. Let's look at the operation state of the outdoor unit side next. We will first look at the high pressure level. During cooling operation at a room temperature of 81 degrees Fahrenheit, attach a gauge manifold to the outdoor unit and read the pressure value on the high pressure gauge. If the outdoor temperature is 95 degrees Fahrenheit, the high pressure level reads 435.1 pounds per square inch. Next, let's determine the condensation temperature. Obtain the condensation temperature on the saturation curve of R410A using the high pressure level measured with the high pressure gauge. The high pressure level is 435.1 pounds per square inch, so the condensation temperature is 122 degrees Fahrenheit. Let's now measure the expansion valve inlet temperature. Measure the temperature at the inlet pipe of the expansion valve on the outdoor unit with a surface thermometer. The expansion valve inlet temperature reads 113 degrees Fahrenheit. Let's now determine the subcool temperature. We can find this out from the difference between the condensation temperature and expansion valve inlet temperature. The condensation temperature is 122 degrees Fahrenheit, and expansion valve inlet temperature is 113 degrees Fahrenheit. Therefore, the subcool temperature is 9 degrees Fahrenheit. Next, let's measure the discharge gas temperature. We can obtain the value by measuring the temperature of the discharge pipe in the outdoor unit with a surface thermometer. The discharge gas temperature reads 212 degrees Fahrenheit. Precautions must be taken when measuring it because the piping can get hot during operation. Next, let's measure the discharge temperature for the outdoor unit. When the outdoor temperature, or suction temperature, is 95 degrees Fahrenheit, the discharge temperature is measured as 122 degrees Fahrenheit. The outdoor air temperature difference is the difference between the discharge temperature and suction temperature, that is 27 degrees Fahrenheit. The values in the table on the right summarize the pressure and temperature levels on the outdoor unit side under standard operating conditions during cooling. It should be noted that the actual operation levels differ depending on the model. Please use these values on the cooling operation state as a reference. The important readings are the low pressure, superheat temperature, and indoor air temperature difference on the indoor unit side, and high pressure and subcool temperature on the outdoor unit side. According to the operating conditions during heating in the winter, where R410A is used in an air-cooled air conditioner, what would the temperature and pressure levels be in the various points in the indoor and outdoor units? During heating operation, changing the cycle makes the indoor unit side function as a condenser and the outdoor unit side as an evaporator. Let's now take a look at the temperature and pressure levels according to the winter conditions specified in the GIS. According to the standard operating conditions for heating with R410A, the levels are as shown here for the indoor unit side, or in other words, the high temperature, high pressure condenser side. And the levels are as shown here for the outdoor unit side, or in other words, the low temperature, low pressure evaporator side. It should be noted that the actual operation levels differ depending on the model. Please use these values on the heating operation state as a reference. The important readings are the high pressure and indoor air temperature difference on the indoor unit side, and low pressure and superheat temperature on the outdoor unit side.